Let's move on to the topic of average value. Suppose at the x value, x equals 1, we have some height. Maybe the height is 4. Doesn't really matter. And at 2, the height is something different. And at 3, the height is something different. And something different altogether at 4. If I wanted to find the average value of f of x, you might say the average height of f of x. The average value of f of x, now this is discrete because it's integer values 1, 2, 3, and 4, and nothing in between. I want to find the average value of f of x, the average height, if you will. So I would add up the heights, the sum of the f of x's, dividing by how many ever there were. In this case, I would be dividing by 4, but in general, I'd be dividing by n. Suppose now that my function is not discrete but continuous, so for all values between positive 1 and 4, and I wanted to find its average height. Average value of f of x in this case would be the infinite sum of all these heights f of x. And the infinite sum would be the integral from the starting 1 to the ending 4 of f of x dx. See, that infinite sum comes back? It's the infinite sum from 1 to 4. And then what would I divide by? There are obviously an infinite many numbers between 1 and 4, but I need to divide by a quantity to get the average value of f of x. And you might see here, I'm going to divide by 4 minus 1, the interval. I will summarize that here. The average value of f of x on some interval a to b is going to be the integral over the interval. And that's how I like to say it. Integral over interval. Some of the textbooks publish it like 1 over b minus a times the integral a to b f of x dx, which is the same thing. I just prefer to say integral over interval. It helps me to remember the formula. So we are asked to find the average value of each of these functions on a particular interval. So here I'm going to say the average value of f of x on 0 to 2 is the integral over the interval. There we have it. Now we already did this math earlier. The integral from 0 to 2 of that function was from another problem, which came out to be 2, and the interval is 2, so the average value is equal to 1. Again, you might think of that as average height, and if the function falls below the x-axis, you could say the height is like negative value. It's kind of hand waving, but you get the point. The average value of the function f is positive 1 in that case. And the second, we're going to say the average value of y on the interval negative 1 to 2, again, is the integral over the interval. 2 minus a negative 1. I believe we did this math also, so it's negative 9/4 divided by 3, and that comes out to be negative 9/12 or negative 3/4. So the average value of this function y is negative 3/4. The point of the next part, part 4, is to show you what you might consider doing when you have a U-substitution. Now, to find the antiderivative, I clearly need a U-substitution. U is 5x cubed plus 1. I'll go through the work here. Du is 15x squared dx, and of course dx is du over 15x squared. So I'm going to make my substitution. 45 over 15, that's going to pull out a 3. And then I'm going to have u squared du. Now here's where the problem changes. this negative 1 is x equals negative 1, and this 2 is x equals 2. But now I've converted to u, so I'm going to change my bounds in terms of u. For my bound of x equals negative 1, and my definition that u equals 5x cubed plus 1, I can determine the corresponding u bound. So u equals 5 times the negative 1 cubed plus 1 is negative 4. So that goes down here. For our other x equals 2, my u is going to be 5 times the 2 cubed plus 1, and gracious, that comes out to be big at 41. So hopefully you see here that I converted from x bounds to u bounds. Now I'm going to do my antiderivative, which is u cubed over 3, or simply u cubed, because 3's will cancel out. And that's going to go from u equals negative 4 to u equals 41. And this allows me to bypass the x altogether. And I'll have 41 to the power of 3 minus a negative 4 to the power of 3. My goodness, that's a huge number. 68,985. This is just an alternative. If you wanted to, you could temporarily not write anything here. Get your antiderivative in terms of x. So that would be an alternative to writing 5x cubed plus 1 to the power of 3. Then we would plug in our x equals negative 1 and our x equals 2. The only reason I like to show this is oftentimes there are multiple choice questions that say this particular integral here equals which one of the others, and this would be one of the choices, making your U-substitution, but the choice would also display the 41 and negative 4 as bounds, and you would need to know how to convert those. Example 2, the integral from 0 to pi of sine of 5x. This is a mini u, but I'll do it anyway. U equals 5x, du is 5 dx, and dx is du over 5. So I know I'm going to pull out a 1/5, and this is going to now become sine of u du. I have to convert my bounds to u bounds, or at least in these examples I do. And the first u bound for x equals 0, that's going to convert to u equals 5 times 0, which is actually still 0. And then for x equals pi, u equals 5 times pi, which is 5 pi. There we go. So this would be an answer to the multiple choice question, but we're going to go ahead and solve the whole thing out. So negative 1/5, because the antiderivative of sine is cosine, negative cosine that is, and 0 to 5 pi, and this will be negative 1/5 times cosine 5 pi minus cosine 0, which gives us negative 1/5, negative 1 minus 1 2/5. Here I wanted to show why we are allowed to get rid of the plus c at the end. If I take this antiderivative to be x cubed over 3, so the 3's cancel out, let's say I include the plus c. And then I evaluate from 0 to 1. Then I'm going to get 1 plus c minus 0 plus c, and if you can see, the c's cancel out always, so there's no need to include the c. In this last part, I have described it as the fundamental theorem of calculus part 2 in disguise. We have some function f prime of x equals e to the negative x squared. We have a condition that f of 1 equals 3, and we're asked to find f of 2. This really works best if you press pause and try to do this on your calculator. Try to figure this out. Some weird things happen, which leads to the motivation of the technique I will show you. Pause in 3, 2, 1. If you tried in your calculator to do the integral of e to the negative x squared power with respect to x, I think you will find that it keeps repeating this, not giving you any additional information. You say, well, thanks, I'm asking for the integral and you keep giving me the integral. That's not very helpful. The reason it's not giving you an antiderivative is there is no antiderivative. It is not integrable. So what we have to do is be clever. Let's use these conditions and say, well, what if I took the integral from 1 to 2 of f prime of x dx? Then by the fundamental theorem of calculus part 2, that would be f of 2 minus f of 1. The calculator will permit us to find it with bounds. See, it might use rectangles or some other algorithm to estimate net area, so it can give us a definite integral even though it's not integrable. So if I do this operation on my calculator now, this is going to give me 0.135, and then that's going to equal f of 2, which I don't know and I want to find, minus f of 1, and f of 1 is given as 3. So with a little bit of algebra, we add 3 to both sides, and therefore f of 2 is equal to 3.135. Isn't that awesome? That's the fundamental theorem of calculus in disguise. Now, we wouldn't have known to do that. We had to introduce these bounds. Again, this value here, too, is the integral from 1 to 2 e to the negative x squared dx. That's our f prime of x. Try example 2, where f prime of x equals e to the x to the cosine x, f of 2 equals 1, find f of 0. So we will say that the integral from 0 to 2, because those are our two conditions here, of e to the x to the cosine x dx, which is the integral from 0 to 2 of f prime of x dx, which by the fundamental theorem of calculus part 2 is f of 2 minus f of 0. We do this on the calculator here, and we get 2.590 to 3 decimal places. F of 2 is given to be 1, minus f of 0 is the thing we want to find. We do our algebra, and f of 0 equals negative 1.590. The end.